All right. Hey, everyone. Thanks for being here at the migration workshop for disputes and arbitration. Today, the agenda is basically to try and get everyone, mostly indexers, up to speed on how disputes and arbitration are going to be working in the decentralized network, not just from a protocol economic standpoint, but also from the sort of hands-on tooling that you'll be using to interact with the disputes mechanism and also how arbitration will play out. So some of this will be a little bit of review for those that were in the protocol town hall yesterday. So bear with me here, but I just want to do a quick overview of the arbitration charter that we showed yesterday, because that's kind of the context for how a lot of this other stuff is going to play out that you'll be diving into later with the tooling. So let me share my screen real quick. Hopefully all of you guys can see this. So one thing I want to emphasize with the arbitration charter, this is the GIP that, like I said, that we went through yesterday, is that this isn't giving the arbitrator any new capabilities, right? The capabilities of the arbitrator are sort of defined and hard-coded into the smart contracts that are in Solidity that have already been deployed to the network. This is about establishing norms to actually constrain the abilities of the arbitrator and also just add clarity to how they will behave in certain situations that maybe are a little bit difficult to formalize in code, or at least haven't been formalized yet. So since a lot of this is going to be reviewed for some of you, I'm going to try and move through this pretty quickly. Most of you should know what the arbitrator does at this point. There's effectively two types of disputes that, I guess you could say three, but query and indexing disputes is what the arbitrator decides the outcome of. And query disputes have two subtypes. One is the single query attestation, where it's just the fisherman disputing an indexer directly. And then another is where a fisherman uses two indexers to kind of effectively dispute each other. A big part of what felt important to us in writing this proposal was that indexers felt confident to participate in this kind of early stage of the network without the fear of being punished for things that are outside their reasonable control or outside of what they could be reasonably expected to do from like a diligence perspective. And so a big part of that is we don't expect all indexers to be graph node core developers. We think that would be bad for decentralization if that was a requirement. So the arbitrator has the discretion, using this draw outcome mechanism to decide disputes as draws if there's a reasonable evidence that it was due to a determinism bug in GraphNode or some other software that the kind of core developers have shipped to indexers. We've seen these in the past. The protocol is still under rapid development, so it's not unreasonable to think that these would come up again in the future. Another one here that we mentioned yesterday was double jeopardy. Indexers shouldn't be slashable for the same offense twice. Unfortunately, today, the attestation data structure doesn't have any replay protection. So that means, for a specific query request response pair, the indexer can only be slashed once. And which, effectively means a single mistake can't be compounded, by someone just repeatedly creating disputes for that mistake. Furthermore, there's going to be a statute of limitations on how long ago a fault may have occurred for an indexer to be disputed, at least according to this proposal. The reason for that is twofold. One is that attackers very commonly will just exit the protocol immediately. So we didn't want to create any asymmetry between, sort of the assumptions that an attacker can expect versus an honest indexer. And then the second is that if there was no statute of limitations, the longer an indexer participated in the protocol, the more likely they would be to accumulate some fault at some point in their past, right? And so we don't also want to punish indexers for being long-time honest participants in the protocol by saying that, hey, you're just constantly accumulating risk of being slashed for something you did at some point in the past. So we think the statute of limitations kind of achieves that. This proposal has it set at basically 2 thawing periods. So 56 epochs, mainly to give the arbitrator, a nice buffer to still do its job. This should be pretty straightforward, but disputes can't be decided as in anyone's favor if the data isn't available to look at the dispute. So hopefully we'll get to some of this in the tooling, but if so as you know, the attestation structure just has like the content hash of a query in it, right? It doesn't have the entire query body itself. That wouldn't really be practical to store on chain or emit in a Solidity event. So the dispute mechanism kind of relies on the fact that these query requests are posted to IPFS so that the arbitrator can actually find the query, when it's time to settle a dispute. Furthermore, this is kind of the case for a lot of parts of the protocol, but the subgraph has to be available, right? If the subgraph manifest and mappings and schema aren't available on IPFS, then again, the arbitrator can't really recreate the work of the query to decide whether the work was done correctly or not. This clause is about setting a cap on the amount of times that an indexer can be slashed for queries during an allocation. And the reason that this is important is that an indexer only submits one proof of indexing per allocation, and thus one instance of possible slashing for that allocation. Whereas we fully expect indexers to serve millions of queries per allocation. And so if each of those queries was slashable, and even if the slashing percentage was like really small, like it could have been like a fraction of a percent, that would still be potentially enough to wipe out, an indexer's entire stake in a single allocation, due to a determinism bug, for example, that, let's say for the sake of argument that the arbitrator wasn't aware of. And that we felt would put an undue disincentive for indexers to serve queries. And so we wanted to create some clarity around that there is a sort of bounded downside risk for serving queries during an allocation. This also piggybacks some of the work that Ariel presented yesterday of separating the slashing percentages in the protocol for indexing and querying. So today it's just a single parameter across the protocol. An indexing dispute and a query dispute are punished equally. But in the future, if that proposal is accepted, then we'll be able to parameterize the query slashing percentage lower than the indexing slashing percentage for this reason. Valid proofs of indexing for a given epoch. It's the correct behavior for an indexer is to submit a proof of indexing for the first block of the epoch in which they closed an allocation. Right now, the closed allocation transaction doesn't have an epoch argument or parameter. So there's no way to fail that transaction if for some reason, let's say due to blockchain congestion, it actually ends up getting mined during the next epoch. So for that reason, if a proof of indexing is incorrect for the epoch in which an allocation was closed, but it is correct for the previous allocation, then that dispute would be a draw. It's basically sort of there's a little grace window there. In the future, we might add that argument to the close allocation method in the future proposal, in which case, some of this stuff could be more automated. And then the last one, this doesn't really impact the indexers, but this is just more about the arbitrator is expected to settle disputes in a timely manner, and it kind of defines what that means. And so the rest of this GIP is just rationale for some of the stuff that we just talked through. But I guess I'll pause there. Yesterday we didn't get a lot of time for questions, so are there any questions specifically on the contents of this charter? Zorro/Oliver, I know you had some feedback in the forums. Haven't totally incorporated that in here yet. Was there anything you wanted to actually discuss with respect to this? Or anyone else if they have any questions or comments. Hopefully this is super clear. Cool. All right. Well, if there's no questions there, then I think we can hand it off to Ford, who will be walking you guys through how to use the indexer agent. It looks like we actually do have a question. Is there a rule that fishermen and arbitrators should be independent? There isn't a rule like that in the charter right now, and it's impossible to enforce at the protocol level. Yeah, I guess I would have to understand the motivation behind the question. If it's that you wouldn't want the same like indexers to be assigned to, I guess your concern is that you don't want a fisherman to basically submit a dispute and then just arbitrate themselves. It's really impossible to enforce that. So there's sort of a degree of, I guess, trust that the arbitrator has right now in terms of, its role that's been assigned by decentralized governance. So one of the things that the charter sort of does outline is removal of the arbitrator. And so if the arbitrator is, a sort of obvious fault of the arbitrator would be to settle disputes incorrectly. And that would absolutely be ground for removal by, decentralized governance, in this case, the Graph Council. It looks like Zorro was muted by Martin. Oliver, did you have anything you wanted to add here?
Nothing to add as such. I mean, I left my some of the feedback in the forum post, and certainly some things that I've learned more since you shared the entire charter. A couple of things we can certainly dig into as we review certain chapters. So I'm good for now.
Cool. Yeah, thank you. So yeah, this has been posted to the forum for about a week or so. Oliver had some great feedback in there that we'll try and incorporate. So I encourage you guys to take a look at that. Obviously, this affects indexers quite a bit, so we look forward to your feedback. And with that, I'll hand it off to Ford, who will be walking through. So the slashing penalty, that's going to be covered in a separate GIP. I actually don't recall off the top of my head what the latest number we've been playing around with. It's definitely substantially lower than the indexing slashing percentage. I would guess somewhere around 1%, but I don't think that's finalized yet. And yeah, and feel free to keep posting questions in chat. We'll move on to Ford for now, but we'll have some time for Q&A at the end, and we can cover this stuff as well. So Ford will be talking through the indexer agent, which is used for, among many other things, detecting bad POIs from other indexers. So I'll hand it off to Ford.
All right, thanks, Brandon. So to start, I'm gonna just do an overview of how proofs of indexing work, because that's an important part of this overall mechanism. So a proof of indexing is a cryptographically strong digest that the graph node uses to prove that has done the work of indexing a specific subgraph deployment and that it has the correct data for that deployment. What do I mean by cryptographically strong here? There is no chance of collisions between different proof of indexing, so they will be unique, and it does not leak information. So you cannot use a POI from another indexer to try to derive one for yourself, for example. Each POI is specific to a deployment, an indexer address, and a block number. So a POI basically declares that you've indexed that specific subgraph to that block, and it also includes your indexer address for uniqueness. The information in the POI is exposed by the graph node indexing node GraphQL endpoint, so you can query that on your infrastructure at any point, and that is what the indexer agent uses to compare against the network POIs to try to identify disputes. And a POI is important. It must be submitted with an allocation close transaction in order for that allocation to be eligible for rewards. And that also makes it eligible to be disputed and potentially slashed. So in order to use the POI monitoring mechanism that we've added to the indexer agent, you simply need to turn on POI dispute monitoring using the startup argument or using the corresponding environment variable. And what the feature does is it monitors POIs that have been submitted on the network, and it creates reference POIs from your indexer, and it compares those in order to identify potential disputes. So if the reference POIs that it generates do not match the POI that was submitted on chain, it'll flag that as a potential dispute. And then what it does is it stores those potential disputes in a database table called POI disputes that you can then later reference to submit disputes on chain. We've also added a command to the indexer CLI, a disputes get command, so that you can view all allocations that have been flagged as potentials. And I've been running this on my machine, and so I'm just going to show you guys what the output of some of this might look like. So here's my indexer agent running. You can see a log here that shows that it has monitored disputable allocations on chain and has found some valid allocations and no potential disputes in that run. And then I'm going to go over here into the indexer CLI, and what I can do is I can call that disputes get command and list any potential disputes that have been flagged. So you can see here, I have, I think, 8 disputes that have been flagged. And you can see the information from those allocations. You can see the indexer that had submitted that allocation. You can see the proof that was submitted with that allocation, the allocation amount, etc. So you can look at this to look at more metadata about the allocations that have been flagged. And for example, one thing that stands out here is you can see these FE proof of indexings that are clearly not valid. And those were test POIs that we've submitted on chain on testnet to test this. Of course, you can also go to the database and explore the data. And just to show you guys overall numbers, I've taken that database table and made a few charts. And so I've broken up the allocations that have been submitted on chain overall. And here are the potential disputes that have been identified. So not too many on testnet. Broken out by deployment, and this kind of just gives you a good overview of what's been going on testnet and how you can look at this data. And then once you've identified potential disputes, the next step would be to look a little bit closer at them, identify ones you might want to submit as disputes. And then we have another tool that Ariel is going to talk about here for actually submitting those disputes. But before we go to Ariel, do we have any questions about that?
I had one question that I'll be the rubber duck for. So you mentioned that the graph node has an endpoint for returning the POI. Does that API take the indexer's public key as a argument, or is the indexer agent the one that's actually computing the final proof of indexing?
Yeah, so that endpoint does take the indexer address as an argument, along with the deployment ID and a block identifier. And so in normal operation, your indexer will use your indexer address to create POIs and then submit those. But when you're checking against another indexer, you'll use their address to create that POI that's unique to them. There's like a base POI that's stored in the database, and then that's combined with the indexer address, the deployment ID, and block number to create a unique digest.
Any other question?
Some people are seeing themselves on the testnet list. Yeah, so if there's nothing else, then I guess Ariel will take the stage and walk through the submitting of disputes.
Yeah, I'll share my screen. I want to show how the dispute process works related to the on-chain part. The first thing that you need to do is to identify a potential dispute, like Ford showed. But then there's a process of submitting that dispute on-chain to a contract. So the disputes are currently managed by a contract called the Dispute Manager that's deployed in like with these addresses that you see here in mainnet and Rinkeby. And you can check the contract code anytime by looking at Etherscan because it's verified. This is the implementation. I was looking at the proxy. So the first thing you need to do is to interact with this contract by creating a dispute, passing the information related to the allocation ID or the query that is wrong. And for doing that, you can use any tool because the contract is open and it's out there, and you can use Remix, you can use Etherscan, but we created a tool to do that easily, a CLI tool. The first things you probably want to know are some relevant network parameters. The dispute process works by doing slashing on indexers, and the percentage of the stake that will be slashed can be checked in this URL. If you go to network, you will see that variable here, 2.5%. And this is set by governance and is stored in the dispute manager contract that I show. So this dispute manager, whenever you present a dispute and it's resolved by the arbitration, will talk with the staking contract and will slash based on the indexer stake and this 2.5%. Okay. So that's one of the important variables that you want to see. Then there's a different governance parameter related to disputes, that is the percentage of the slash that the submitter of the dispute will get. So when a dispute is resolved, accepted, and the indexer is slashed, 50% of that slash is going to go to the submitter of the dispute. That's another value that is set by governance. And the last one is the bond that you need to present as a submitter. If you find a dispute and you want to dispute that and present that in the dispute manager, you need to deposit 10,000 GRT now. Okay, so that's something that you need to have before creating a dispute. As I was saying before, we have a CLI that you can install. Don't do it now because it's not published, but I will publish the script after this meeting and probably in some hours. But you can install with npm. It's a script in TypeScript, and it will give you like different commands that you can use to interact with the dispute manager contract. You will need this information, the endpoint to query for trust for the POIs. This is the one that Ford mentioned. So this script will test if whatever you are presenting is valid dispute or not, so we can catch any like issue before submitting to the dispute manager. You need an Ethereum node because it's going to interact with the contracts. You need the network subgraph URL because it's going to query for allocations and some information. to present in the script. You will need a private key, so you send the transaction to the dispute manager contract, and you need the funds, the 10K if you are going to dispute. Then all the things are configurable. You can use the environment you want. Like you can use an Ethereum node for mainnet or for Rinkeby and interact with any of these deployed contracts. So the graph dispute CLI provides these commands, a command to list the active disputes, and it will show active disputes and unresolved disputes with the details. A show command that you can pass the dispute ID and see the details of that particular dispute. Some commands to create indexing disputes or query disputes. In these cases, the parameters that you need to pass change a bit. In the case of an indexing dispute, you will pass the allocation ID that you find it's using a bad proof. In the case of a query dispute, you will present an attestation that the indexer is going to send you, okay, as a response. Then you can pass the deposit that I said, like the minimum deposit is 10K, but you can pass any number about that 10K. And then it also provides some commands that will be used for arbitration to reject, accept, or draw the dispute. This is going to be used by the arbitrators to basically decide what to do with that dispute. So I'm going to go like a bit about the different like type of disputes and what's happening behind and what the CLI is doing to help the process. As Brandon said, that there's an arbitration charter, and the arbitrators will look at the charter and decide on what to do with a dispute based on that. But the script is going to help to validate things before the dispute is submitted to follow the arbitration charter and help the arbitrators. So Ford already described what a POI is, and the like it's related with an allocation ID that is closed on an epoch. What you need to do, you need to know is that anyone can dispute. It's like a public process, like anyone can call this create dispute function. So anyone that is monitoring the network can create a dispute on an allocation ID, but there are some conditions. Well, first, this is an example of the how you would call the CLI to create the transaction that will submit the dispute. Okay, in this case, I'm submitting this allocation ID with this deposit, and these are all the endpoints I'm going to use. Okay. So when you're creating this dispute, there are some things that are enforced by the contract. You can't create multiple disputes on the same allocation. That's one thing. The allocation must exist in the staking contract. If you pass like a random allocation ID, it's not going to work. It's going to revert. The indexer must have some stake. You can't dispute like an indexer that doesn't have any funds or doesn't exist, basically. And the deposit bond should be above the minimum required. So those things are enforced by the contract. But the CLI is going to test a number of things to help to follow the charter. These things are it's not going to let you create a dispute on some allocation that was already slashed to basically follow this double jeopardy protection in the charter. It's also going to check if the allocation is old and it's like older than the 2 thawing periods in the charter. It's going to like issue a warning so you don't submit that dispute, because basically the arbitrators will reject or draw. And it's going to check that data availability. Like it's going to test that the content is there, so the dispute can be reproduced by the arbitrators. Okay. So this is the case for indexing rewards. Okay, you don't need many input variables. Like you need the allocation ID, but this is going to test a number of things by querying the subgraph, querying IPFS for the data, and querying the context. Okay. Then the other type of dispute is the query disputes. Indexers are responding to queries, and it's going to sign attestations based on the response. And these attestations can be used as a receipt that if the consumer finds the query to be invalid, it can use this attestation to submit file a dispute. Okay. So in this case, we will use, instead of create indexing, we'll create a query dispute, and we will pass the bytes. This is basically this structure, the attestation, but in byte format. And this will submit a query dispute in the dispute manager contract. Okay. An additional information that needs to be available is the actual query that you did, and that needs to be available in IPFS, because this whole process is, we need to reproduce the dispute so we can know if it's right or wrong. So this the request needs to be available in IPFS. So some conditions enforced by the contract. Only one dispute with the same data and submitter can be active. If any of these conditions will revert if it's not fulfilled. The indexer must have a available stake, and the deposit must be over the minimum required. Again, in this case, the CLI will help to enforce the charter by not submitting disputes that are going to be drawn by the arbitrator. Okay, this will help, like, not getting like a lot of submissions on things that are going to be drawn. So it will help the indexers, consumers, and the arbitration process. Any questions so far?
We've got a couple questions that have come up in chat. They're not specifically related to the tooling. Maybe we can loop back on those at the end if you have more to get through here. Okay.
Then there's these are the I would say 2 commands that most people will use to file disputes. After doing some analysis, probably like using the agent detection and maybe looking at the information manually a bit, and then the last step will be to use this CLI to have reassurance about the checks the script is doing, and then getting the dispute submitted. I'm not sure if it's obvious, but submitting a dispute means a transaction in the blockchain, so you'll need to pay for some gas cost for creating the dispute. Then there are some tools that can be used by anyone, by the arbitrators and anyone wanting to file a dispute. Is this command. Again, you need to pass a number of endpoints that this script will use, and it's going to list some information about the dispute. So in this case, you see the dispute ID that is created in the contract, the type of dispute. In this case, an indexing dispute is undecided because the arbitrator needs to resolve this dispute. You will see the addresses of the indexer and the submitter, the subgraph deployment, some information about the allocation that this dispute is related. Like you'll see the ID, when the allocation was created, and the block hash, and the actual POI submitted by the indexer. And then the script will do some checks to see if the reference POI match. Like in this case, you see like match is false and it's false again. These are 2 checks because as Brandon mentioned, we are checking the epoch when the allocation was closed and the epoch before that, to ensure that we have some time, like if some congestion in the network happens, you have more time to mine the transaction. So in this case, the reference POIs doesn't match with this one. In this case, there's a lot of leading zeros. It's a bit strange, and it's a bad proof. So the arbitrator can assume that this POI is really a wrong one, and then decide to accept the dispute. Okay, but anyone can use this tool to list the current disputes in the contract. Then the resolution process can be the resolution process can follow like with an accept, a rejection, or a draw. Accepting a dispute means that the indexer will be slashed, the deposit will be returned to the fisherman, and 50% of the slash will go to the submitter, and the rest will be burned. The other condition could be to be rejected. That means that the indexers won't be slashed, and the fisherman will lose all the deposit. And the last condition will be a draw, where the indexer is not slashed, and the fisherman will not lose the deposit, basically. Okay, so that's more like the neutral one. One note is that the dispute ID that I showed here is created within the contract. It's basically a hash of like some fields to avoid duplication of the dispute you present. So you will find the dispute ID after you create the dispute. Okay. I'm thinking I'm covering most of the things. The package is not yet published, but we'll publish in the following hours. Okay.
I have a question on the resolution structure. Is it meaningful and also feasible to consider an escalating penalty structure on the indexer side that might start at a lower base for a first-time offense, but then escalates progressively with more offenses being recorded?
Yeah, I think these types of things are all in the design space. One thing actually that relates to is another question that I saw come up from Stake Machine, which basically asked, if an indexer knows that he submitted a bad POI, can he open a dispute on itself and minimize slashing effect in any case? The reason I think both your questions are related is because it relates to like, what are the true penalties for being slashed? So the simple answer to Stake Machine's question is yes. If you wanted to preemptively slash yourself as the fisherman, then in theory, you're reducing your economic penalty for that single incident by 50% with the current parameters. When you think of the system as a whole, another way to look at slashing and disputes is that this is part of your permanent record under this indexer's account. And so this is something that's both visible to delegators, but it's also visible to consumers. So I don't know how many of you guys were in, I'm trying to think of the last time we did a workshop on indexer selection. It might have been even the testnet, might have been, after the network launch, but the indexer selection algorithm that's run by both the gateway and the query engine, it actually takes into account a whole list of factors that it basically applies utility functions to. So some of those are things like performance, throughput, latency, availability, are you always online? What's your efficiency with respect to negotiation? Do you accurately advertise prices? But some of that is also economic security and reputation. And so, so to your point, Zorro, about compounding penalties, even if in the slashing mechanism itself, there's not a compounding penalty, I would say that already today there is a compounding penalty with respect to reputation, because if an indexer is slashed once or twice, that can be seen by an indexer selection algorithm or a delegator as, an honest mistake. If an indexer is slashed repeatedly, I think it's very likely that you would see delegators start to exit that indexer, as well as consumers start to deny list that indexer completely from receiving query volume. So That's not to say that there's not more you could do in the future, but it's worth noting that some of that I think already exists. That dynamic already exists today in the protocol. But great question. So a few more questions we had that came in chat. I think this is a really interesting one. Josh asked, assuming an indexer is acting honestly, what are examples of situations that may result in an indexer being disputed? There's a couple that I can list off the top of my head, and then I think Ford might be able to elaborate on some more that we've seen. But one example could be like your Ethereum provider or Ethereum node that you're running being faulty, right? So either like, right now the graph node relies on calls to like ETH get logs to make sure that it's getting events. We've seen cases in the past where either events were missed or events were duplicated by the Ethereum node or Ethereum node provider. And so that could be a cause outside of graph node that leads to determinism issues because you're basically double processing or missing an event. Another one that we talked about yesterday, this will be a new kind of case, is that graph node starting with 1.0 release is going to adopt Semver conventions. So the idea is that the protocol at any given point will have like an official major version of graph node, but that minor versions are meant to be backwards compatible with one another with respect to the proofs of indexing and queries that would be produced. So you could imagine like a bug that the core developers introduce where they just accidentally don't, they introduce something that doesn't comply with those Semver conventions. So an indexer upgrades to a newer minor version thinking, hey, my proofs of indexing and attestations will be the same, when in fact, an inconsistency was introduced. So that would be another one. I think we've seen things in the past with, kind of like transient, like block reorgs and, network events, putting the database into inconsistent states. Ford, do you have any other color to add on like past determinism bugs that we've seen?
Yeah, I mean, that's like a good intro. Another big class of things that could lead to a POI not matching a trusted reference is configuration issues. Maybe your indexer agent is talking to a mainnet subgraph and getting the incorrect epoch value, and so it submits for the wrong block number, or other small issues like that often will lead to the POI being valid but not lining up with the arbitration charter and being for the correct epoch. So it's definitely becoming more important to be very prudent about your versioning of your software and making sure you're checking everything in your configs, especially on mainnet.
Yeah, that's a great point. And we've gotten pretty good at, I'd say, debugging and root causing a lot of these determinism bugs. I know Ford and Ariel spent a lot of time actually when implementing the indexer agent cross-checking, specifically looking at that last class of determinism bugs. So one thing I forgot to, I guess, drill down on the arbitration charter was just, what do you do when you see yourself being disputed on chain? Like, what should your next steps be? The arbitration charter has a placeholder link right now to a spot in the forums. And that's basically where the arbitrator, which today is a multi-sig set to Ariel, Dave, and Giannis, that's where that root cause analysis can happen. So like if you were, if you believe that the proof of indexing was incorrect because you thought the epoch was wrong, or or you think there's a determinism bug in the the graph node, or you think there was an issue with your Ethereum node provider, that's the place where we can share logs. We can we can kind of investigate. It's meant to be a collaborative process. We recognize that the network is still kind of in this bootstrapping early phase. And so the idea is to work with people as much as possible that are trying to behave honestly in the network. I think, so Alex is asking, will these cases of determinism bugs be settled as a draw or rejected? They will be settled as a draw because it's also not the fisherman's fault if, from the fisherman's perspective, they are correct that there is an inconsistent proof of indexing.
One follow-up question to your earlier comment. Is there a chance an indexer might not even know that there's a dispute case being logged against him, and all of a sudden, the first time he hears about it is the decision itself?
Certainly that's a possibility. I mean, being an indexer in the graph is much more of an engaged, I would say, active activity than being an indexer, or excuse me, being a validator in, like, let's say like a blockchain network where you could like spin up a Raspberry Pi and like set it and forget it. So, you know, we've already seen this with like the subgraph migration. I would say there was like a, you know, certain set of indexers that were like ready and saw that the subgraphs were migrating and like took action immediately. And we saw other indexers were a little bit slower to respond because they're sort of not actively engaged in the network. So I'd say at the phase that we're at now, it is primarily the indexer's responsibility to be active and engaged and make sure that they're, you know, participating with the mechanisms of the protocol responsibly. In the future, there should be a lot more tooling available. So someone already asked in the chat whether there was a way to query the disputes outside of looking at the contracts directly. There is a disputes entity in the network subgraph, which a lot of community members have already been using to build their sort of third-party, you know, dashboards and network explorers. I fully expect that as you know, as we see more usage of the mechanism, we'll see a lot more of that incorporated into those explorers. It's also on the roadmap for some of the web apps products that EdgeNode is working on, although it won't be part of it likely won't be part of the MVP release that's happening at the end of the phase 3 migration. So Joseph from Figma asked, is it only the query fees that are slashed and not the indexer's deposit? No, indexer's stake is slashed in the case of disputes. And I believe to your follow-up question, what about rebate pool rewards? So for the indexer, like once rewards are settled, I believe they're all part of the same like pool of funds from the perspective of the protocol. So at the point that once they're in there, they're slashable. I don't think the part of the rebate pool that goes to like delegators, that wouldn't be slashable, for example. Yes, right now, so someone asked, is this over the allocated stake on the specific subgraph? Today, the way that it works in the mechanism is that it is over the total indexer stake. I actually, just as an aside, I do believe there would be, there's valid reasons for shifting that to the allocated stake. That's kind of on my personal backlog of proposals to work on, but today, the way that it works in the contracts is that it's the total stake owned by the indexer. Any other, Ariel, Ford, do you see any other questions we haven't addressed yet?
There's one question is about whether or not an indexer can compare their POI with a reference prior to submitting their allocation close. That's a good question. It would be prudent to have some extra checks. However, you would need to work with another trusted indexer and use their POI or ask them to compare, because this is not something that I would recommend you expose to other indexers, because then they'll be able to spoof proof of indexing.
Yeah, so by sharing your proof of indexing with other indexers, you're basically sharing your reward with other indexers.
Yeah, exactly. But it's something to think about, and I hope that that'll not be necessary as we hone in on determinism and hardening all of our various systems. But you may want to work with some other trusted indexers to do some validation in these earlier stages.
One question that sounds like we might have missed was, how long does it take to resolve a dispute? So the expectation that's set in the arbitration charter is that the arbitrator should attempt to settle dispute within one thawing period. That's kind of logical, since an attacker would presumably exit immediately, and then we only have one thawing period to slash them. In practice, that might not always be possible. So this isn't the kind of thing that's going to, like, if an arbitrator is not going to be removed for not always meeting that goal, specifically because the arbitrator needs to be able to recreate the work that's implied in the dispute. And so sometimes that's going to be a quick and easy process. Sometimes that might be a longer process. As I mentioned earlier, the initial arbitrators that are set in the multi-sig are that are part of the arbitrator multi-sig rather, are Ariel, Dave, and Giannis. And so they're sort of proactively running, kind of their indexer to basically be in a position where they can reproduce work very quickly. But if a dispute, for example, were to come up for like some subgraph that somehow they're not already indexing, then it might take longer as they, index this new subgraph from scratch to kind of get to the, block where that proof of indexing dispute or query dispute is relevant. Any other questions before we wrap up? I guess I'll close with some final thoughts on another mechanism. This isn't something we'll have time to go in depth on today, but it's something that maybe would be a good topic for a future workshop. It's just the role of the subgraph oracle in securing the network. So it kind of, your last question kind of made me think of this, which is just, what if what if the malicious indexer submits a, subgraph that's impossible for the arbitrator to index and reproduce the work on, or is exceedingly difficult for, some known set of reasons. So that's the role of the subgraph oracle. There will be a subgraph oracle charter GIP at some point in the future to clarify the processes that role should take in a way that similar way that we've done to the arbitrator. The main action that the subgraph oracle takes, as many of you know, is that they disable indexing rewards on, they have the ability to disable indexing rewards on specific subgraphs. The reason that this ends up acting as a kind of penalty of sorts is that, if an attacker does signal a bunch on a subgraph that, for example, no one can index or no one can reasonably be expected to index, and then they also allocate a bunch on that as an indexer, they have the opportunity cost of, the indexer allocated stake, but then also as a curator, they're paying this curation tax. And so when that subgraph gets disabled for indexing rewards, effectively the curation tax that they've paid is now worthless. And so part of the role of the oracle is disabling subgraphs on a short enough time frame to make those sorts of attacks unprofitable. Stake Machine is asking, what about serving bad data for queries? So that's the second big category of disputes that we talked about. I think it was the first category or the second category that Ariel showed in the tooling, but that's the query attestation disputes. So there's a couple of different types of those, but yeah, absolutely, there's a dispute process for those.
I do have a couple of thoughts going back to the arbitration charter and considerations to add to the role of arbitrators. One would be a consideration for introducing a post-mortem process on a dispute following the arbitration decision, a review of what is the likelihood of that sort of dispute to recur in the future, and can there be introduced mechanisms or protocol improvements to address that gap. And here would be the arbitrator's role to do sort of like a mini review of that, and then possibly engage the community on ideas.
Yeah, I think that's a great idea. I think a really natural place for that would be, I guess, like the forum thread where where, the arbitrator is intended to engage with the honest indexer that made a mistake. And yeah, the final step in that could be to post some kind of postmortem, but also like, I guess an opinion, so to speak,
Right.
of why they decided the outcome the way that they did.
The other thought was the idea of an appeal process, which I don't think I've seen in the arbitration charter, and I don't know if that is something to consider, but the idea would be that an indexer has an opportunity to appeal the decision of the arbitration, not necessarily based on content, but maybe based on process.
Yeah, so that's a really interesting idea. One thought I had here that I didn't put into the arbitration charter because mainly the charter was about non-code changes, but I think it could be interesting to put like a waiting period on the slashing. That's something we could explore in the future. So like the arbitrator makes their decision and the indexer stake at that point can't exit the protocol. So it's sort of like frozen, but maybe they're not slashed right away. And that would actually, give the graph counsel, for example, time to act as like an appeals body if, for some reason the arbitrator needed to be removed, if they were making like a string of bad decisions. So I think these are really great suggestions that could either be worked into either this charter or, just future proposals for improving and hardening the arbitration mechanism. Do you have any other thoughts, Oliver? I think you posted a couple other things in the forum as well.
Yeah, I think most of the other items that I've posted on the forum have since been addressed by just getting deeper insight into the charter, and also as far as I had one comment on the penalty and reward levels, but Ariel walked us through that today as well. So I think what I've brought up were the ones that I think are still maybe valid ideas to consider. Everything else I think is addressed.
Cool, thank you. So Josh asked, where do the reference POIs come from that the indexers are comparing to? Ariel, I'm assuming it means the reference ones that showed up in your tooling, if I understand the question correctly.
Seems Ariel might be frozen, but
I thought he was just being stoic.
In Ariel's script, you can supply a trusted index or endpoint. A graph node has what we call the index node status endpoint. That's a GraphQL endpoint that includes the proof of indexing query. So in the indexer agent monitoring tool I showed, that would query your own infrastructure and compare. In Ariel's dispute script, you can point that to any graph node that you have access to that you trust.
Cool. So it looks like we're at the top of the hour here. If you guys have any other questions, please find us in Discord, the forums. You kind of know how to reach us. But yeah, thanks for everyone for your questions, for showing up, and yeah, good luck with the rest of the migration workshops.